Section 2 is substitution. In Section 1, we graph two equations to find the intersection point. The intersection point is the only point shared by the two lines. It's the only point shared by the two lines. So we called that the solution. The one ordered pair that makes both equations true at the same time. The x coordinates are the same, the y coordinates are the same. So what are some problems maybe that we've discovered along the way with graphing that makes graphing not the best way to find the solution? Yeah, graphing is, I want to use the word inherently sloppy or challenging or difficult. It's not easy to get a perfect line on your graph. Why not? Because you haven't had enough coffee and your hands are shaking? Or you've had too much coffee and your hands are shaking? Or you don't drink coffee at all? Why not? It's just how it is? We had a couple story problems, and we had to change our scale. Remember that one? Scale is a bad thing too. So graphing is sloppy, like we're bad at graphing, but scale makes things weird. It becomes hard to graph. It's hard to pick out the actual intersection point unless they land exactly at a nice spot. Anything else? In order to graph, how do we graph equations? What do we have to do? We like using slope-intercept form, but what if I'm not in slope-intercept form? I got to rewrite it. And sometimes, when I'm rewriting, when I rewrite my equation, sometimes I wind up with a y-intercept that's really strange, or a slope that's really difficult to try to graph. So graphing can be very challenging for those reasons. There are others. But typically in algebra, we like to get exact answers and know for sure that we're right. That's the whole point of algebra. Graphing is more like an estimate. Most of the time, graphing is more of an estimate than an actual exact answer. The problems that we did in Section 1 were really nice because you always landed at a nice, easy ordered pair. That was intentional. Most of the time, that's not true. So it turns out that we can use algebra to solve systems of equations, and that's what we're doing in Section 2. By using algebra, we eliminate all of these problems because the algebra gives us the exact answer, and that's a really nice thing. So all these problems that we see with graphing, they go away. And then we'll have exact answers, and we'll know for sure that we're right. There's several ways we can solve equations using algebra. The first one in this section that we're going to learn is called substitution. It's the same thing, same idea as if you go over to the Maverick and you say, can I get change for $1? You're going to get $1 back, but it's going to look different. One is the same as the other, though. You've substituted a dollar bill for 4 quarters. All right, substitution makes use of the fact that at the intersection point, both equations are equal. That's the whole point of what we're doing in this chapter. If I have two lines, where they cross, that ordered pair right there works for both equations, which means that that x for this line is the exact same as the x for this line. And the y coordinate for this line is exactly the same as the y coordinate for this line, because the y is the same in both equations. Then I can trade one y for the other. Because the x is exactly the same in both equations, then I can trade one x for the other. That's what substitution is. All right. So, which means the x in both equations is the same number, and the y in both equations is the same number, and because of that, it's like changing 4 quarters for $1. You can do that, and everybody's going to be happy. Nobody's getting gypped out of their money. Okay. So, solve the system using substitution. This is a system of equations. Two equations sitting here. They will cross. We could graph them and find out that they cross. And then we could pick out probably where they cross and have an ordered pair, and that would be our solution. We want to do it now with algebra, though. Now notice that I've made the y's here the same color. Why did I do that? Because they're the same. What I'm doing is I'm saying when these two equations cross, these y's here are exactly the same. They're equal to each other. So therefore, because this y is 3x, I can take this y and substitute it in right there for that y. If I do that, then I'm going to rewrite this as x plus what y is. What is y? Y is 3x. It tells me right here, y equals 3x. So I can take the 3x and substitute it in for y right there. X plus 3x equals negative 32. Change 4 quarters for $1. Combine like terms once you've substituted in. Sometimes you'll have a distributive property that you have to do, and then combine like terms. But this time all we have to do is combine like terms. So what's x plus 3x? 4x equals negative 32. And then just solve the equation for x. Divide both sides by 4, and we get x equals negative, probably, negative 8. So now we know what x is. Now these two lines, if I sketch a little graph over here, y equals 3x will probably kind of look like that. And then x plus y equals negative 32. Well, that's probably going to look something like this. Okay? I don't know what the scale is on here. It's just a sketch. It doesn't really matter. But these two lines are going to cross. And what we just figured out is that they cross when x is negative 8. So obviously I have this in the totally wrong spot, but it doesn't matter. It's just a sketch. So x is negative 8. But I have an ordered pair where they cross. So I have negative 8 comma something. How do I find that something? Well, I take the fact that x is equal to negative 8 and I substitute it back in up here for x in one of my two equations. It doesn't make any difference which equation you pick. Whichever one looks easier is the one you're going to pick. So which one looks easier? The top one. So I'm going to write y equals 3 times x is negative 8. Y equals negative 24. So I have x is negative 8 and y is negative 24. So now I know my ordered pair is negative 8 comma negative 24. That's my answer. We have to have an answer, an ordered pair just like we did in section 1 because the answer is where the two lines cross. And that happens in an ordered pair. So I have to say the ordered pair. I have to find what x has to be and I have to find what y has to be. You don't have to substitute in for y. You can substitute in for either variable. It doesn't make any difference. But one equation needs to be solved for a variable. So you can say y is this or x is this. Therefore, I can substitute it in to the other equation. Second problem. I have y equals 2x plus 7. I have y equals x minus 1. I'm trying to solve this using substitution. So, I know that when these two lines cross, they will be same x and the same y. So what I'm doing is I'm saying when these lines cross, this y right here is going to be exactly the same as this y right here. Or I could say that this x right here is going to be exactly the same as this x right here because the two lines are crossing. We have this going on. The x coordinates are the same. The y coordinates are the same. Kind of like 4 quarters is the same as $1 bill. Okay? So, I'm going to trade. I like this y right here. I know that this y is this. So I'm going to take what this y is and substitute it in right there for that y. Because y is 2x plus 7. So instead of writing y equals x minus 1, I'm going to write what y is. Y is 2x plus 7. And that equals x minus 1. This right here was y. y equals x minus 1, y equals x minus 1. But y is, from this equation, 2x plus 7. So I just traded them. I substituted. Now that I've done that, I can solve the equation for x. So what should I do? Do I have any like terms to combine? No. Save division for last. We want to get all the x's on one side, all the numbers on the other side. This is straight back to like chapter 2. Subtract x from both sides. That works. And then what do I get? Okay, now what? Subtract 7 from both sides, and we get x equals negative 8. All right, that's a coincidence, by the way. These are two completely different problems. It's just coincidence that we wound up with negative 8 again. You can get any number. All right. We have the x-coordinate of our ordered pair. How do we find the y-coordinate? Yep, substitute what you just got back into one of the two equations here. Which one looks like it's probably easier to work with? The x minus 1 one? The bottom one? Sure. So we'll go y equals, x is negative 8 minus 1. Well, what's negative 8 minus 1? Negative 9. So now I know that x equals negative 8 and y equals negative 9. So my answer is negative 8, comma, negative 9. What should we do? Always in math class after we finish a problem. We should check our answers. So let's check both of these to see if they actually work. For, I'll change colors so that we don't get confused. For negative 8 comma negative 24, plug it into the first equation, and I have negative 24 equals 3 times negative 8. Is that true? Yeah. And in the bottom equation, I have x, so that's negative 8, plus y, which is negative 24, equals negative 32. Is that true? Yes. So I did actually find where these two lines cross using that substitution method. And on the bottom equation, if I take the negative 8 and the negative 9 and I substitute them in, then I have in the top equation, negative 9 equals 2 times negative 8 plus 7. Well, 2 times negative 8 is what? Negative 16 plus 7. Is that a true statement? Negative 16 plus 7? Yeah, that's negative 9. And the bottom equation, we have negative 9 equals negative 8 minus 1. Is that a true statement? Yeah. So these two equations do work. I can check them pretty easily just by plugging in those numbers, just like we were doing in section 1. You do want to check your work here. Substitution method, like I said, is not the easiest thing to start off with. But as you do problems correctly and you get the right answer, it will click. It'll be like a little light bulb going on over your head, and then you won't have any problems with substitution anymore. So keep struggling through it. We do have more problems that we can do, so let's go ahead and do another one here. Okay, sometimes you will need to solve one equation for a variable before you can use substitution. Those last two problems, we already had equations solved for y. You don't have to solve for y. Always look for an easy variable. Easy variables are ones that you don't have to use division on. You're trying to not divide, because if you divide, you can wind up with fractions, and nobody likes working with fractions. If I can avoid fractions, I avoid fractions too, even though I say I like fractions. So I can't imagine, if you don't like fractions, how revolting it must be to find fractions. So I'm trying to help you out. Look for the easy variable to solve for. That's going to be a variable with a coefficient of 1. You won't see a number in front of the variable. That's going to be the easy one to solve for. So in this system of equations right here, notice that we're not solved for a variable right now. But in which equation and which variable should I solve for? The second equation, yes. And why? How come I see this y right here and I want to solve for that y? Yeah, it's easy. All I got to do is add 2x to both sides, and I have that equation solved for y instantly. So I can do that. Plus 2x, and now I have y equals 2x minus 3. Now I know what y is. Y is 2x minus 3. So I can take what y is and substitute it into that other equation right there for y. I used this equation to get this one. I got to substitute this into the other equation. Otherwise, I'm just going to get like 2 equals 2 or something, and that's bad. By the way, if you wind up with 2 equals 2, you probably did something wrong. Okay, so I know what y is. It's 2x minus 3. So I'm going to take 2x minus 3 and plug it in right here for y, which means I'm going to write this equation over again. It's just that when I get to y, I'm going to use parentheses and substitute in what y is. So I have this 3 times what y is. Y is 2x minus 3. And then I continue the equation. Plus 4x equals 14. That's how you substitute.